Hey guys, we're going to go through lesson 3.3, which is all about graphing exponential functions. All right, we are going to just be creating some functions from verbal descriptions. Remember, the formula that we're going to use, and we talked about it in lesson 3.2, is this function here. Principal times 1 plus the rate raised to the time, or the x power. Your variable is that exponent. Julie is a biologist. She's been tracking the population of dragonflies. Her first count was 223 dragonflies. Unfortunately, the population has been decreasing 3.6% each year. Because the population is decreasing, this type of function is called exponential decay. And all exponential decay means is that base, or that rate of change, is going to be somewhere between 0 and 1. It's going to be a decimal or a fraction. So, what is the rate of change for this dragonfly population? I'm sorry, the first question says, what is the y-intercept for the dragonfly population? What is our starting amount? 223 dragonflies. What is the rate of decay for the dragonfly population? Well, it's decaying by 3.6%. So remember, we take that 3.6, divide it by 100, and we get 0.36. But it's negative because it's decaying. So we have 1 minus 0.036, which gives us this number, 0.964. Now notice how that number is less than 1, between 0 and 1, so it's a decay. Now let's take those pieces and plug them into our function rule. So f of x is going to equal 223 times 0.964 raised to the x power. What will a graph of this look like? Something like this. The number of dragonflies is our y-intercept, how much we started with, and that's where our graph should cross the y-axis. And then because the base was less than 1, this function is decreasing. Now, this module has a video embedded in it. I will not take time on this video to make you watch another video, but he is just comparing the different two different formulas to figure out how the y-intercept and the rate of change affect the outcome for the sales. All right, go through, spend some time, watch this video, and do some comparing here. Here's another example of some more comparing functions. Julian is a video game designer. He has 2 options for leveling point system in the upcoming game. His options are f of x, which they give us the equation for, and g of x, which they give us the graph for. Oh no, there's 2 different ways of representing the function. How are we going to compare them? Okay, well, relax. We can use the key features of the graph to help us out. So the y-intercept of this graph, where does it cross the y-axis? It looks like it's crossing at 15. Okay, and then the rate of growth, or the rate of change here, again, we're going to have to go through and use the graph to help us find this out. All right, let's talk about shifting the graphs. I understand that these formulas look super crazy, but they're really not that bad. Okay, a vertical shift. Remember, vertical is something that goes up or down. If we're going to shift our graph up, or we're going to shift it down, it means we're going to take this function, whatever it is, however it looks, and we're going to move it up. Or we can take the same function and move it down. When we do that, all we have to remember for these is that, let's move down here. Okay, here are the key points. In order to do a vertical shift, you want to, nope, go back. Where is it? Nope. Okay, so in order to do a vertical shift, right, you want to add 2 units to the function. That will shift it up. In order to move the function down, you subtract 2 units from it. Okay, so whatever your function is, it doesn't matter what the function is. If we are adding a number to it, it's going up. Okay, again, who cares what the function is? If we are subtracting a number from it, then our function is going to shift down. Okay, similar rules apply to horizontal shifts, meaning when we are moving our graph from left to right. So, for horizontal shifts, if you add a number to the x value, not to the function, only to the x value, if you add a number to that, it will move your graph to the left. If you subtract a number from that, it will move your graph to the right. So remember, when you are transforming or shifting your graph, if the number you're adding is inside of the parentheses, right in there with the x value, then that is a horizontal shift. If the number that you are adding or subtracting to your function is on the outside of your function, for example, like here, then that is a vertical shift, moving it up and down. All right. And then finally, when we have negative exponents for our graph, you can clearly see by looking here that it will create a mirror image. It will do a reflection across the graph. So you see that when we're negating our x values. It changes everything, every x value from a positive to a negative. Now, the nice thing about eLearning is that it has practice problems. So again, they have problems you can click through and see how you're doing. And at the end of each lesson, there is a nice little review sheet that has all the major points that you need to know. Okay, so for this lesson, the major things you want to know is that exponential growth is when the graph is increasing, going from left to right, and the base must be greater than 1. Exponential decay is when the graph is decreasing from left to right or going down, and the base is between 0 and 1. When we compare functions, we want to focus on those key features like the y-intercept. Is it increasing or decreasing? We want to look at the rate of growth and the average rate of change, that slope formula, y2 minus y1 over x2 minus x1, okay? And then when we are shifting our graphs, what effect will it have when I add or subtract a number outside of the function? It will move it up and down. The graph will move left and right if I'm adding or subtracting a number just to the x value. And if I'm negating all of my x's, then that will be a reflection over the y-axis. All right, go ahead and try out the quiz. Good luck.